All right, today we're going to turn to 2009, question 4, part B. All right, at a glance, this is a bit of a weird, funky looking question. We got one thing on our table, we got a movable pulley, and we got a freely hanging mass. But actually, as we look a little bit closer to it, one of the core things is that it's a smooth table, so that's nice, no friction to worry about. So this is certainly getting a bit easier. We're not given too many numbers, we get to play with M1 and M2. So first part, find the tension in the strings. This is a very standard start to our questions. We'll draw force diagrams, F equals MA, and we'll find the tension. And the second one, we need to find the value of K. But again, it's nice to have this, a hint for what the thing should look like. This should catch us out. It should help us see if we make any problems. So let's start drawing these one by one. All right, there is M1. And it has a force of T in the string. Okay, and it's got a force going downwards, but we don't really care about it because it's on a smooth table. So that's pretty easy. Here is C. Well, it's got two bits of the string pulling it up, so T and T there. It will have a force down, and C, if we look at our question, is going to be mass M2, M2G. Okay, those are subscripts, so make sure you don't let them slip into big real numbers where you can confuse them. And finally, we're going to have our 1 kilo mass, and 1 is very nice because it's going to make life a bit simpler. This is going to pull down with mg, which is of course just g, and the string coming up t. Now the next step in all these things is to figure out which way is it going to move. So again, it doesn't really matter if we get this wrong once we're consistent. So I'm going to assume that this one is going to move over this way with acceleration a, which means this one is probably going to move upwards with acceleration b, and our movable pulley is going to go down, acceleration a plus b over 2. Okay, you get this step right, and then everything really falls together. There's a bit of funky algebra ahead of us, but it's just normal algebra once we have these in place. Okay, F equals ma. Well, in this case, it's nice and straightforward. T equals m1a. Grand. This one here we assume is going down. So m2g minus 2t equals m2, and we're going to say our acceleration is a plus b over 2. And that's of course because each of them is giving them a little bit of string, and it's being shared out over 2 loops, so it has to be halved. And finally here, this one's going to be going up, so t minus g equals, technically speaking, 1b, just because it's the mass, but that'll disappear nicely. All right, so we're looking for the tension in the string. So what we'll do is we'll sub in A and B. Pop them into the sky here. So bring the sky down. We have m2g minus 2t. I'll leave the 2 outside here for the moment while we bring everything in. Now, let's just bring this guy down here. So, A equals T over M1. No harm to write this stuff out. That's T over M1. And B equals T minus G. We pretty much had that anyway. Plus T minus G. Okay, now let's start working through it. So we're going nice, slow, steady. We're going to multiply all these terms out and then try and combine everything. T on one side, everything that's not T on the other side. Let's do T. M1 plus T M2 over 2 large G over 2. This is looking messy, but hey, we're going to work our way through it. Now, next step is get T's on one side, things that aren't T on the other side. So I've got 2 T's here, and I'll pop this guy over now. So we have M2G plus M2G over 2. That's grand, that's pretty nice. Equals TM2 to M1 bring this guy over, plus 2t. All right. 3 over 2 m2g, combining those two, is t, and let's see what we got left on this one here. m2 over 2 m1 plus m2 over 2 plus 2. Lovely, no common factors, nothing neat, nothing tidy. So buckle in, it's going to be a little bit of fun here. We're just going to have to make a common factor, all right, because I need to get all of this under this. I certainly don't want to have fractions under fractions, making life too hard. So let's see, can we pull out a common factor in this? Of course, 2m1 is going to be our common factor. It is m2 over 2m1 plus m1 m2 over 2m1 plus 4m1 over 2m1. Okay, I'm going to be slow and careful on these ones to make sure we don't kind of have any little glitches and screw ups along the way. And that equals t vector of m2 plus m1 m2 4m1 all over 2m1. Okay, at this stage we're going to bring ourselves up. We just need to bring this guy over here. So we're going to flip it around. So what we have up here now is t equals 3 over 2, leave that one outside for the moment, by 2 m1 m2 g all over all right, looks delightful. So let's see, can we multiply these things out a small little bit more? And there's not much we can do in terms of common factors and bits and pieces here. Our 2 0 cancel, and this, so basically our tension is going to equal 3 m1 m2g all over m2 plus m1 m2 plus 4 m1. Truly horrible equation, but there we have it, and that is actually what our tension is. Now we can start part 2 on a separate page in case we need it. I'm actually not sure if we do. This might be a fairly handy little bit, but we want to find pulley C will remain at rest if all this happens. Well, C at rest, therefore net forces are forces, we can't spell and think at the same time, forces equals 0. All right, so if we go back to our first one here, the net forces is 2t upwards and m2g down. All right, so therefore we find that m2g minus 2t equals 0. Therefore m2g equals 2t, if you like a slightly neater equation. So what we're going to do is we're going to sub this in. Now bear in mind, you could have of course done this another way. You could have looked at it from the point of view of the accelerations. If the acceleration was 0, it's at rest. So this one just looked a bit easier for me because we figured out an equation for t. So we're going to use this equation for t over here. All right, sub in t. Don't forget the 2. All right, 3 m1 m2g. And this is as ugly as I get, but don't worry, things are going to get simpler. Okay, so first of all, we can see really nicely our m2Gs are going to cancel, so they can go straight away. So we end up with 1 equals 6m1 all over m2 plus m1 m2 plus 4m1. Now I know it seems a bit tedious banging out all these things, but do be careful skipping steps. It's really easy to do things like drop the 2 and forget it. So bring these over here now. m2 plus m1 m2 4m1 equals 6m1. Okay, I can see a simplification coming here. So we will knock off, bring this guy over here for the moment. And we'll end up with minus 2 equals 0. Okay, so where are we going next? If we look at these terms and look what we have before, these are all up there. We don't have any combined terms, but we do have things over m2, over m1. So let's try that out. Let's see if we get, let's divide everything. Enough space here. We do divide by m1, m2. Okay, you're going to see which way this is going to go. I think we'll actually do this up here just to make sure we have space. m2 over m1, m2. Okay, I'll write this out because if you don't like your algebra, this is going to be a little bit funky. m1, m2 plus m1, m2 over m1, m2 minus 2m1 over m1, m2. Now, of course, equals 0. Cancel, cancel, cancel. So what we're left with here is 1 over m1 plus 1 minus 2 over m2 equals 0. Have a little look at what we're supposed to be finding. Now we're really in the right direction. So we need that as a positive, that as a negative. So these both come out to this side. You can see what k is going to equal to. So move them across. 1 equals 2 over m2 minus 1 over m1. Therefore k equals 1. Nice and tidy. All right. So that was a little bit of a funky step in it, but just stick with it. Try things out, experiment around it, and you'll find these little bits and pieces.